Hello and welcome to the fourth video in our Year 9 Indices series. Today we'll be talking about what scientific notation is, its definition, and what we can use it for. So let's dive straight into it. What is scientific notation? Well, one of the most immediate applications of indices is in scientific notation. So let's consider a scenario, right? A group of scientists are writing a chemistry article and they want to discuss the mass of hydrogen, the atom of hydrogen. But a hydrogen atom weighs approximately 0.000. Now, I'm not going to waste my breath saying all those zeros, but you can see it is an incredibly small amount. And this is clearly tedious. It's too stupid to just write out several times, right? So the scientists instead, what they do is they condense that massive number, or that it's a very small number, but really long to write out. They condense it into 1.674 times 10 to the negative 24. And this is what we call scientific notation. Now, what are the main principles of scientific notation? Well, we need a number which is bigger than or equal to 1, but less than 10. So this first number has to be between 1 and 10. That's the first rule. Then we have to have a multiplication sign, obviously, and then it has to be multiplied by 10 to the power of some whole number. Okay, this has to be a whole number. Very important. Now, how do we actually know that this is actually this number? Like, how do we know it's 10 to negative 24, not negative 23? Well, the logic behind that I will discuss right now. If we have 10 to the power of negative 1, we know that's 1 over 10 to the power of positive 1, which is 1 over 10, and that's equal to 0.1 as a decimal. Similarly, we can say that 10 to the power of negative 2 is equal to 1 over 10 squared, which is equal to 1 over 100. And if this negative indices stuff is not making sense, please refer to our negative indices video. I think is the second video in our Year 9 indices series. Now that we've got 1 over 100, that's equal to 0.01. I'm going to do one more for you. So 10 to the power of negative 3 is 1 over 10 to the power of positive 3, which is 1 over 1,000, which is equal to 0.001. So you can see how 10 to the negative 3 had 2 zeros between the decimal point and our number. 10 to the negative 2 had 1 decimal point. 10 to the negative 1 had no decimal points. So here we've been told that there's 23 zeros between our decimal point and our 1. So that is why it's 10 to the negative 24. Okay? Now, that being said, let's look at some easy examples and try and put this into practice. So here we have 0.000023. How do we write that in scientific notation? So remember, the first number has to be between 1 and 10. And in this case, it's clearly obvious that it has to be 2. Now, it has to be 2.3, right? Now, we need to multiply that by 10 to the power of some whole number. Now, what is that number going to be? The way I like to do this is I just like to count the decimal points. So we have 1, 2, 3, 4, 5, because the decimal point has to end up between the 2 and the 3. So it is 5 decimal points. We're moving it to the right, so it's going to be negative. Okay, so when we're moving decimal points to the right, it's going to be a negative power. When we're moving decimal points to the left, it's going to be a positive power. So we're going to have 2.3 times 10 to the power of negative 5. And that will be our answer for question 1. Now let's have a go at question 2. Now here we don't have a decimal point, so it's probably a good idea to actually insert it where it should be. It's after the 3, right? Now, where are we going to move the decimal point? We're going to be moving it between the 6 and the 2, because remember, we want our first number to be between 1 and 10. So we're going to make it 6.23 times. Now, how many places did I have to move the decimal point? I had to move it 1, 2, and 2 to the left, which means positive. So it's going to be 6.23 times 10 to the power of 2, which makes sense, right? Because 10 squared is 100. If you do 100 times 6.23, you're going to get 623. So that makes sense. Now let's go through question 3. Okay, so with question 3, once again, where do I want the decimal point? I want it after my first non-zero number, which is here, in between the 6 and the 7. So I'm going to be getting 6.7 times. Now, how many spots do I have to move the decimal place? 1, 2, 3. So 3 decimal points I had to move. And which way was it? To the right, which means it's going to be 10 to the power of -3, which makes sense. And finally, we have this last number over here. So our decimal point is obviously after the 0 because it's a whole number. Where do we want to move it? We want to move it between the 2 and the 1. So that's going to be 2.1004. You could add another 0, but it's not really that important. So I'm just going to leave it like this. Times 10 to the power of. Now, how many times do I have to move the decimal point? So it's from here. I want to get it to there. So 1, 2, 3, 4, 5. That's 5 spots to the left, which means it's going to be 10 to the power of +5. So hopefully you've got an understanding of how to use scientific notation and how to convert those weird, really long looking numbers to a bit more simpler, shorter looking numbers. Now let's look at going the other way around. So we've talked about going from numbers to scientific notation. How do we go from scientific notation back to the numbers? Now this is slightly different, right? Remember with our previous example, when we were going with positive powers, we were moving the decimal point to the left. In this instance, when we're going from scientific notation back to numbers, I want you to move the decimal point to the right if it's positive and to the left if it's negative. So with this one, we've got 2.1 times 10 to the power of 5. So I've got 2.1 times 10 to the power of 5. What this 10 to the power of 5 means is move the decimal point 5 spaces to the right. So let's do that. 1, 2, 3, 4, 5. Now, obviously, when you don't have anything there, you just fill them out with zeros. So 0, 0, and 0. So our answer is actually just going to be 210,000. That's going to be our final answer. And that makes sense because remember, 10 to the power of 5 is equal to 1 with 5 zeros after it, so 100,000. And if we're doing 100,000 times 2.1, well, obviously we're going to get 210,000. Now let's look at this example here. We're timesing by 10 to the power of -3. So when we're timesing by negative indices here, we're going to be moving the decimal point to the left. So left by 3 spaces. So we're going 1, 2, 3. And there's a 0 and a 0 here. So therefore, our answer is going to be 0. So this is what we've got to 00512. And that is our answer. Finally, we've got this one over here. We're going to be moving the decimal point 6 spots to the right. So that's going to be 7.104. We're moving it once, twice, 3 times, 4, 5, 6. Fill out the zeros. So our final answer is going to be 7104000 or 7,104,000. So hopefully that makes sense. It's slightly different to when we're going from numbers to scientific notation. And finally, we have a harder example. Evaluate this in scientific notation. So let's just use our index laws first, and then let's use scientific notation at the end, because normally that's going to be our method of approach. We use scientific notation at our final answer. So let's evaluate. We've got 3 times 10 to the 4 squared, which means we're squaring everything inside the brackets. So squaring the 3 gives us 9. Squaring the 10 to the power of 4 gives us 10 to the 8. Remember, index laws. Then we're multiplying by 8 times 10 to the power of 6. What does that equal? 9 times 8 is 72. So we've got 72 here. And 10 to the power of 8 times 10 to the power of 6, if we add those indices together, we're going to get 8 plus 6, which is 14. So we get 72 times 10 to the 14. Now, whilst this is correct, it is not scientific notation. Remember when I talked about what scientific notation was? This number has to be between 1 and 10. So what do? Essentially, the decimal point is here. So all we need to do is move the decimal point over here. And if we move the decimal point to the left, in this instance, we're going to be adding. We're going to be adding to the power. And so we're going to end up with 7.2 times 10 to the 15. And that is going to be our final answer. So remember, when we're going from numbers to scientific notation, and we're moving the decimal point to the left, we're increasing. We're using positive powers of 10. When we're going from scientific notation back to numbers, we're basically using those up. So that's why we're moving to the right. And hopefully that makes sense. It is a bit of a tricky concept, but the more questions you do, which will be in our homework, the better you'll get at this. So that concludes our video on scientific notation for year 9. Our next video will be discussing significant figures, and yeah, hope to catch you in the next one.